Velocity and acceleration. The velocity is the rate of change of distance with respect to time. Often if we're doing distance in meters and time in seconds, velocity will be the rate of change of distance with respect to time, meters per second. And if x is a distance function as a function of time, then dx dt is the rate of change of distance with respect to time. Well, that's the velocity, isn't it? So v equals dx dt. The speed would be the magnitude of the velocity. So if you're having a frame of reference, here's x, here's y, and here's 0, and you are here facing in the forwards positive direction, so that's your frame of reference, then if you were going 30, the velocity was 30, it would be that way. If the velocity was minus 30, then you'd be going forwards at minus 30, so you'd be going backwards at 30, wouldn't you? But in both instances, one would give you v as 30, one would give you v as minus 30, but in both instances, even though the velocity is different, the speed would be 30 miles per hour, because that's the magnitude of the velocity. The acceleration, on the other hand, is the rate of change of velocity with respect to time. We write dv dt, and so velocity is dx dt, so we can differentiate that again to get the second derivative. So acceleration is just d2x by dt squared. An alternative formula that we don't use very often is listed here. The acceleration is dv dt, as we said, and we can write that by the chain rule as dv dx dx dt. Well, there's dv dx, and dx dt is the velocity, isn't it? So another formula for acceleration is v dv dx. If v is a function of x, that might be useful there. So x is a function of t here. V equals, well, we want dx dt, don't we? That's the velocity. So differentiate, that goes to 0, this goes to 6, lots of 1, minus 3t squared. So there's our velocity function. And the acceleration, which is d2x by dt squared, so differentiate this again then. This goes to 0, minus 6t. So when t is 2, and the velocity will be just the modulus of this, won't it? So when t equals 2, v is equal to, put 2 in here, 2 squared is 4, 3 fours are 12, 6 minus 12 is minus 6. Suppose it's in meters and seconds then. And the acceleration, when t is 2, is minus 12. Meters per second is the velocity, the rate of change with velocity with respect to time, meters per second per second. The speed, which is equal to just the modulus of the minus 6. So it's 6 meters per second. Just drop the negative if there is one to drop. Next problem now. We've got this problem here, so let's have a look at it. We're told this formula here, and we want to find out various things. I'll write them down as we go and just run you through them. So x is equal to 3 plus sine t. Okay, find the velocity and, oh, that's problem 3. We've got problem 2 first, haven't we? So let's do problem 2, which is here. H is equal to 20t minus 5t squared. A ball is, the height h, I've got the picture here, is thrown up vertically upwards from the ground level, and it's given by this formula. X equals, so it's an x actually, not h. So x is equal to then 20t minus 5t squared. We're told that. Find the velocity and the acceleration first of all. Well, the velocity, just differentiate dx dt, 20 then, minus 10t. The acceleration, differentiate this, that goes to 0, this is minus 10. That's the velocity and acceleration. What's the velocity and acceleration when t equals 1? Well, v will equal, put 1 in, 20 minus 10 is 10 meters per second then, and the acceleration is minus 10. And when t equals 3, the velocity is equal to, put 3 in, 20 minus 30 is minus 10. And the acceleration is still minus 10 meters per second per second. Okay. How long does it take the ball to reach its highest point, and what is its greatest height? Well, at the top of the highest point, the velocity is 0. So v equals 0. Let's see what we get. We've got v is 20 minus 10t equals 0. That tells us that 10t equals 20. And that tells us that t is equal to 20 over 10, which is 2 seconds. So when t is 2 then, we're at the highest point, and v equals 0. And its greatest height, well, we know what the x is, don't we? T equals 2. So when t equals 2, I'll squeeze it in here. What does x equal? 20 2s are 40, minus 5 2 squared is 4, 5 4s are 20. 40 minus 20 is 20. So the height, and I've put it here, is 20 meters. Okay, so that's good. So we've done that. How long does it take for the ball to fall back down to the ground? Well, we've got the formula for x, haven't we? So this is the height above the ground, and we just let it equal 0. And let's see what we get. So I'll put it down here for a moment. 20t minus 5t squared equals 0. Take a 5t out as common. We've got 4 minus t equals 0. That tells us that t is 0 at the start, and then t equals 4, isn't it? So when t equals 4, it's hit the ground again. And the question asks, and its speed on impact, well, velocity we know at any given time. 20 minus 10t. 20 minus 10 times 4. 40. 20 minus 40 is minus 20 meters per second. And that's the impact velocity, isn't it? So now we've done that example, I'll just create some more room and we'll look at the final example. So our final example now. I'll leave some room up here as well. Okay. So we've got this spring. It's given by x equals 3 plus sine t. It's the distance away from this where it's suspended. There's the distance x, and there's the weight suspended by a spring. And it moves according to this rule. There's the distance away from the wall. What's the velocity? Well, velocity, just differentiate dx dt, is cos t. And the acceleration, differentiate again, minus sine t. And then we need to find that when t is pi over 2. So t equals pi over 2 then, which is 90 degrees. Cos 90 is 0. And the acceleration is equal to sine 90 is 1 minus 1 meter per second. When t equals pi, cos pi is minus 1. And the acceleration minus sine pi is 0. Acceleration is 0. So that's the second problem, part 1 rather. Find when the particle is at its highest and lowest points and its acceleration at these points. Highest and lowest. Well, basically this swings from, sine t goes from minus 1 to 1, doesn't it, on the graph? Okay, so the biggest distance away would be 4. Lowest. So lowest is, so let's go back to the question. So find when the particle is at its highest and lowest points, when the particle. Okay, so lowest is when t equals here. When it's equal to minus 1. Remember the sine curve? Here's the sine. CAST. So sine gets up to 1 here. So that would be the biggest value, and that would be the lowest when it's pi over 2. Pi over 2, 5 pi over 2, 9 pi over 2, just go around one full circle. And x would be equal to 4. and highest. That's when the sine value comes back to -1, which is around here, isn't it? At 3π/2. And then around again is 7π/2. And then 11π/2, just adding 2 pi's full circles. And then x would equal 2. And its acceleration at these points. Well, we know acceleration is this. So a is equal to minus sine of t minus 1 at the lowest. So it's gone to its lowest and its acceleration is -1. And when it's its highest, a is equal to minus sine 3π/2 minus -1 is 1. So that's what the acceleration is at those points. Find the maximum and minimum magnitudes of the acceleration and where the particle then is. Maximum and minimum magnitudes of the acceleration. The acceleration is this. The maximum magnitude would be 1 when this is 1. When does the magnitude, which is this, equal 1? So the maximum magnitude of the acceleration is 1. The minimum sine t, min, is equal to 0. And this was sine t magnitude, max is 1. Sine t is 1, magnitude of sine t is 1 here at π/2. 3π/2. 3π/2, isn't it? Then 5π/2. Just adding a pi each time. And then 7π/2, and so on. Just go around to here, and then to here, then to here, then to here. That's when the sine is 1. When it's sine 0, it's 0 here, here, round to here. So t would be equal to 0, pi, 2 pi, 3 pi, and so on. Okay, now the next thing we've got to show, the last thing, okay, so let's just get d2x squared plus x equals 3. Well, this is d2x by dt squared here. Let's just verify it. Minus sine t plus 3 plus sine t equals 3, because the sine t's cancel, which is what we wanted to show. We got the acceleration already here, haven't we? So we put it in there for the acceleration plus the x, which we've already got. I've substituted them in and they are equal to 3.